The next situation I have is I wanted to tape a video on segment measures with chords and tangents to circles. So we're going to be solving for different segment measures. Now, there's a few different formulas that we have, and the first one deals with whenever I have two chords that are intersecting inside a circle. And so I love these different equations or formulas over here that are in the clouds because it tells me that part, so I have AE part times EB part is equal to DE part multiplied by EC part. So what that means is looking over, and I have a lot of these already done, but if we look over here, that means 3 times 4, so 3 times 4 is equal to 6 times x. And then I would end up just solving for x, and x is going to equal 2. In this situation on number 1, I have 8 times 6 is going to be 48, and then it's going to equal to 12x. And then I divide both sides by 12, and it's going to equal to 4. Then I have a little bit more difficult situation where I have variables involved. So I'm going to multiply 8 times x plus 8 and set it equal to 9 times the quantity of x plus 6. And whenever I distribute, I end up with 8x plus 64 is equal to 9x plus 54. And whenever I solve it, it's going to equal to x is equal to 10. Now I know that it's going a little bit fast. You can always pause me. When I find out if x is equal to 10, then I have to go and I say, okay, I want to actually find out what PG line segment is. So I take 10, I add 8, and then it's 18. The next type of segment that we're going to solve for is when we have a tangent, and it is, and then I have involved a right triangle where I have the hypotenuse is going to be 5, but this is end up being a secant. So I can use the Pythagorean theorem to solve for the other side in this situation, because if I have a radius and it intersects a tangent line, then I know that this is going to end up being a right angle. So situations like this are number 4 and number 5. So if I look down here at the bottom of the page, I just have right triangles, and I have 5 squared plus 12 squared is equal to 13 squared, and I know that 25 plus 144 is 169. So it is a tangent line because it forms a right triangle, and the Pythagorean theorem is true. Now number 5 is a little bit different. I have that the radius is 8 because I'm told that the radius is 8 here, so the radius here is going to be 8. And I know that the segment from here to here is 17. So I'm going to solve for one of the sides of the equation. So 17 squared is equal to 8 squared plus x squared. And I have 17 squared minus 8 squared is going to end up being 225. And I just used my calculator to do that, is equal to x squared, and then take the square root of 225, and it is 15. Now, you can continue on. They get a little bit more complicated. We won't have any of these like this on our test, but this does involve FOIL, and we did these in class. So there are a couple of other theorems that end up being on page 11, and that is whenever I have two secants that intersect outside a circle. And I love this equation right here in this cloud says my external part times the whole segment is equal to my external part times the whole segment. So that is the formula that we use when we have two secants that are intersecting outside of the circle, and it's these secants intersect the circle twice. Now we have a certain situation where I have two tangents that intersect, and their vexes at the intersect outside at the same. Is where the tangent to each other. Use this second. The last one I have where lines are, and I have a tangent line, secant. Tangent line, a measure of the tangent line and square is the external part of the secant, the whole secant. There's a couple of these, or these forms, these equations. So on here at the bottom page is like and the secant. So I have time external is my whole x equal to 8 times 6, which is 15. And I just use it and I solve for x. So I distribute. 49 plus 7x is equal to 112. Subtract 49 from both sides, 7x is equal to 63, and then divide it by 7, and x is equal to 9. This number 2 is the exact same thing. I have 9 times x plus 9 is equal to 10 times 27. And I solve for x by setting up an algebraic equation. Number 3 is the exact same situation. Number 4 is a little bit different, and these are two tangent lines, and they intersect at a point external. So these two, and I can end up setting these two equal to each other and solving for x. So I set 2x plus 2 is equal to 5x minus 4. Subtract 2 from both sides. 2x is equal to 5x minus 6. I subtract 5x from both sides, divide by -3, and so x is equal to 2. And then it asks what jk is, and it'll be 4, which is number 5. Next looks a little bit different. This is tangent here, and I start 5, the external times the whole. Then I just 100 is 25x. Subtract 2 from both sides, solve equal to 15. Again, in this situation, I solve, and I set squared 9, and I solve squared is equal